Now let's practice how to graph a derivative of a function. Sketch a graph of the f prime of x for the function shown in the figure below. Now we identify some features of the graph and connect them to the properties of the graph of f prime of x. We can see that on x equals to -3, there's a horizontal tangent line here. Horizontal tangent line. That means f prime of -3 equals to 0, right? And also on x equals to 2, I believe that there's also an horizontal tangent line. Which is f prime of 2 equals to 0. Now we find the critical points, and then we look at on which interval they're increasing or decreasing. Look at that. On the interval -5 to -3, we found that the function is increasing. So we can interpret that f prime of x is greater than 0. But on the interval of -3 to 2, we found that the function is decreasing. So that f prime of x is smaller than 0. Then again, on the interval 2 to 5, the function is increasing. So again, f prime of x is greater than 0. Now we've done analyzing the graph. We can use the information derived from this one to sketch a graph that has the approximate shape of a graph of f prime of x, but not necessarily with the proper scale. Okay, we move to this. So the turning point of the curve should be -3 and 2, because the graph becomes from increasing to decreasing. So the derivative is from positive to negative and then to positive. So we can kind of graph that like this. This is kind of weird. So we can see that it's positive here, negative here, and positive again here. And when x equals to -3 and 2, the function the derivative is equal to 0. So that's a graph of the derivative of the function.